Alright, here we go. Polynomial functions. We're going to be just fine today. I gotcha. Light toast. Sit back, tray tables off. We're lifting on. Okay, so we are starting polynomials. We will be doing polynomials for quite some time. Today we're going to focus on adding, subtracting, and multiplying them. It's almost exactly like the complex numbers that we've already done. A couple things you need to know before we get a rolling. Number one, this is a polynomial right here. It's a big boy. This polynomial has 1, 2, 3, 4, 5, 6 terms. We would call that a 6-term polynomial. Now, there's only two things I need from you. Number one, when you write your answers, please be sure that your answers are in standard form. And here's what this means. Look at my exponents. What do my exponents do?
They go in order.
They go in order from
greatest to least.
Biggest to smallest, yep. So when you write your answers, we're going to make sure that we do our biggest exponent first and then work our way down to the right. That is called standard form. Last thing that's just a good thing to know is the largest exponent in a polynomial is called its degree. So this would be a 5th degree polynomial. Okay? That's what I need you to know about polynomials. The next thing is just a couple little vocab words that I use a lot. Don't have to have them memorized, but I do say them a lot. I will often refer to polynomials as monomials, binomial, or a trinomial. These are the three special ones. If a polynomial has one tiny little term, like 4x squared, that's it. It's called a monomial because it has one term. Mono means one. Binomial has two terms. Bi like a bicycle. And finally, a trinomial has three terms. Tri means three, like a tricycle. Okay? If you hear me say these words, I'm just referring to how many terms they have. If a polynomial ever has more than 3 terms, then it's really lame. We just say like 4 term, 5 term, 6 term. It doesn't have a fancy word. But if I ever say these words, it refers to how many terms it has. I usually say binomial and trinomial the most. And now it's time to get going. Since we're just starting polynomials, we do need to make sure we know how to add, subtract, and multiply them. Okay, we add them the same way we add imaginary numbers together, and we multiply them almost the same way as well. So we're going to start with adding. When we're adding or subtracting, all you need to do is combine like terms. And just remember, a like term is when the variable and exponents are exactly the same. As long as they are exactly the same, you can combine them. Good? Yes? There's a lot of words there, but that's all that means. Okay, example 1, flip her open. Example number 1. Is this the mild guide? Or should we just skip to the medium?
Mild.
Okay. Here we have 2 trinomials because they have 3 terms each. Trinomial, trinomial. And in between our trinomials, we have a plus sign, which means we are going to do what? Add them. We need to just make sure that we can identify our like terms, because we need to make sure we're appropriately adding things together. So I'm going to highlight one of my terms. Does this guy have a like term?
Yeah.
Who's its like term? 5a to the third. And those are like terms not just because they have an a, but because they also have an exponent of 3. Exactly. Okay? Give me another pair of like terms. Positive 6a squared and negative 8a squared. Those are also like terms because they have an a to the second. Last but not least, we got negative 3 and positive 5. Now these are all like terms, and we're just going to make sure that we add them together. Because there's a plus in between. Now, if one of your terms didn't have a like term, and it was just like a loner and didn't have any buddies, you would just drop it down into your answer. It wouldn't combine with anything. Okay, so we want to make sure this is in standard form. So which one should I add together first? The 2a to the third and the 5a to the third. Those have the biggest exponent. I want it first. So add them together. 2a to the third plus 5a to the third is 7a to the third. Now notice, did my exponent change? No. When you add and subtract, your exponents do not change, just the number in front. Multiplying different. Adding and subtracting stays the same. I like to put a little X through these because I'm like, ah, did them. Get them off my sheet. Next, which one should we add together? 6a and negative 8a. Right, that's negative 8. Add them together, go. 6 plus negative 8. We should get negative 2, and our exponent stays the same. A to the second. Blues, done. Finally, we add together purples. Negative 3 plus 5 is positive 2. My exponents go in order. I have no more like terms. I am done. That's it. And now you get to do the medium and spicy. Ready, go! Medium and spicy. That's it, done. Oh, it's just medium. 2 mediums. That's it, you're done. Boom. Answer. That is it, you're done. You added 2 polynomials together. Yes, this is the one time where that is it. Hey, do the mead. Meads. Mead. Medium. Do the 2 mediums. Example 2, example 3. You got it. Just like you did before. Working on example 2. Yeah, does he have any buddies? So you just, no buddies. Find another pair of lines. No buddies. Buddy. If they don't have buddy, you just drop it down. It's part of your answer. Yes. Done. There's only one thing. When you add 2 and negative 2 together, what do you get? 0. Nothing. So we won't even write this term. It's just gone. Because this technically means 1n. So your answer is just that. You don't even need to write the 0, but yes.
I really do got one.
Do the mediums. Medium.
Isn't it?
I got no. Zero.
That's too easy.
Identify your like term.
Go into your that's tough little bobo.
So like, is there any other x to the third? No. Any other x squared?
That's one.
Any other x's? Yes, these can add together. 7 and 5 can add together. Anything that you can't combine, just drop on dead.
Curious. David. Go.
Yeah, you do that.
Oh yeah, buddy.
You're done with example 2, you should be doing example 3. Yes. Nope. I prefer you not.
I think I did.
And I'm putting up example 2 so you can check. If it doesn't have like terms, drop it. Combining the blues, you get 0, so we don't have to write anything. And then 7 plus 5, positive 12. Check it. Try example 3. Yeah, if it's 0, you don't have to put anything. 0 means nothing. So you put down nothing. Beautiful. Now this one. If you like your invisible ones, you can put them in.
Doing number 2 and 3.
Yes, but it's right. All your numbers are these two. You want them in order. Technically, you're
Like a mushroom. Like,
now just put your terms in order.
But I'm not is that what you can put in?
What happened? What happened when you added 7 and -2 together? Now, remember, you want to make the biggest exponent.
You just suck ass.
New order. Alright, let's look at example 3 quick. Now remember, if we want to save ourselves time, we want to make sure we do things in order from biggest exponents to smallest, then we won't have to reorder later. So what are my biggest exponents? The x squareds. So we should do those first so that it's first. You know what I mean? If you don't do it in the right order first, your answer, you're just going to have to re-scramble it into the right order. So 3x squared plus negative 1x squared would be 2x squared. Again, I did my greens first because I want my biggest exponent first. Now I would do my light blues because my x term would go next. Negative 3 plus positive 1 would be negative 2x. And then I would do 7 plus negative 2, giving me 5. No more like terms, and my exponents are biggest to smallest. That is adding. How's adding? Good?
Good.
Because now we will subtract, which is exactly the same. The only difference is instead of adding, we subtract our like terms. Otherwise, exactly identical. Okay, I'm going to go next. Yeah, you want to do the mild or the medium?
Medium. Wait, let's start from sample 1 and down.
You want to do the mild first?
No.
Medium. Medium?
Medium.
Let's do the mild. Okay, so example 2, the mild. We'll do together, and then I'll leave the rest for you. In example 2, the only difference is we subtract instead of add. So when your calculator, instead of putting a plus, you put a minus. It's the only difference. So in example 2, give me a pair of like terms. 5x squared, 2x squared. What else? Negative 3, negative 11. Okay? So now, instead of adding, we are going to subtract. subtract. So be careful when you type it in your calculator. Here we have 5x minus 2x giving us 3x. Now this is a really tricky one. Negative 3 minus negative 11.
Positive 8.
Negative 3 minus negative 11.
Positive 8.
It is, yeah. Type it in. Just practice typing it in. Negative 3 minus negative 11. It should be positive 8. And you're done.
I was correct.
Okay, so that is kind of like when we did the
Complex numbers. Exactly the same.
like
Yeah.
if it's
Right, do the medium and the spicy. The spicy is real spicy, isn't it? Example 1, example 3, ready, go! Yeah. So in this one, what we're connected to?
Oh, sorry.
What do you mean? You know how to do it. You know
I would rather you ask us to, you know what I mean? Especially today.
Well, don't forget your
Right?
variables.
So you are, okay, that sounds, looks good, you got this.
On the other one, just comes on down. That is it. You're done. That's it. Finished.
okay, well,
Are you done with your mild and your spicy? Yes, you are indeed beautiful. That one will just come down. That's no lettering.
do you guys like my face?
Carlita.
You know how they're behind the wall. No, I saw you.
Hey, check example 1. 2 minus 5 gives you negative 3a to the third. 6 minus negative 8 gives you positive 14a squared. And negative 3 minus 5 is negative 8.
Oh, okay.
There is your medium. Oh, did I messed up, didn't I?
Oh, did you?
6 minus, no I didn't. 6 minus negative 8, that's 14. 6 minus a negative 8. The largest exponent. So this is the largest exponent. Yes.
Well, you added 2a and you added 2a, 3 and 5a to your subtracted.
Minus 2 minus 5, negative 3.
Okay, so even though it's a plus, if it's a minus, it's like between the parentheses.
You'll always do whatever's in between the parentheses. Example 3 is the spicy. Here we have 3a to the third and an a to the third. Those are like terms. Remember our variables have to be exactly the same. So negative 2ab squared has to go with the negative 4ab squared. The last one, if you look, the squared is connected to the a, so that has no friends. It's a loner and gets dropped down. Now we just subtract our like terms. 3 minus 1 is 2. Negative 2 minus negative 4 is positive 2ab squared. And the loner gets whoop, dropped down. Oh, what 3? 3 minus 1, 2. Oh, you're saying to the power of 3. Yeah, I just accidentally wrote it 2. That is subtracting. Subtracting and adding. Before we move on to multiplying, which is going to be real quick because you basically already know how to do it, when we add and subtract, did any of our exponents change? When you combine like terms, did the variables change at all? No, only the numbers in front. When you add and subtract, your variables should not ever change. Only the coefficients, the numbers that sit out front. Now multiplying, your exponents are going to change. Don't confuse the two. So on to the world of multiplication. This is the single sheet. Okay, the whole top half of this sheet is just talking about how you set it up. Now we've done the box method before, and it's looked like this, right? So you need to make sure your box size corresponds to the size of your polynomials. This little example 1, if you look, we have 2 terms times another 2 terms. So our box is 2 by 2. You see how they match? So that way, if I did write my terms on the side, everything would have 1 spot. Everything has its own box. Okay, we're not going to solve this one, but this is just setting up. If we had a 3 by 3, that means we have a 3 term times another 3 term, so we need to make our box 3 by 3. So the size of the box you draw depends on how big the polynomials you're multiplying. They're not always exactly the same. Like you could have a 2 term by a 3 term, and you would have to do a 2 by 3 box. So the size of your box depends on how big or small your polynomials are. This was a 2 term and a 2 term, so 2 by 2. 3 term and a 3 term, so we did a 3 by 3. If you had a 2 term and a 3 term, this is what it would look like. Like that. There's many different box shapes, and it all depends on the size of what you're multiplying. So let's go ahead and do, I think you have example 2, yes? You don't have this one, do you? Goodbye. Why won't you go away? Okay, example 2. Our first polynomial has how many terms? 2 terms. Our second polynomial has how many terms? 2. So we are going to make a 2 by 2 box. I didn't like my box. 2 by 2. Like that, 2 by 2. Take your first polynomial, and you can either put it on the top or the bottom. It doesn't matter, or the top or the side. Doesn't matter. 3x minus 4. Don't forget your positives and negatives. My second polynomial, I'm going to put on the top 4x and positive 3. Now, when we fill in our box, we are going to multiply. If you look, our polynomials were touching, which means we need to multiply them. So, 3x times 4x gives me 12x to the second. When we multiply, we need to look at how many variables we have, and that becomes your exponent. We had an x up there and an x up there. That means 2 x's total, so that's why it became x squared. Okay, let's keep going. 3x times 3. 3x times 3 is 9x. Multiplying. Negative 4 times 4x. Negative 16. X. Last one. Negative 4 times 3. Negative 12. And we didn't have any x's, so don't write any x's. Okay, now we're going to look at our box and figure out what are all of our like terms. So does 12x squared have any like terms inside our box? No other x squareds. What about what other x's do we have? Negative 16x. And then we have negative 12. No like terms. So now we're going to write our final answer. Kind of like when we used to add together the real parts and the imaginary parts. We're going to add together our like terms. 12x squared. No like terms. Write it down. Our x terms we can add together. 9 and negative 16 add up to. Add them up. Negative 7x and negative 12. No like terms. Add it to the end. Boop. All right, example number 3. How many terms does the first polynomial have? How many does the second one have? So you need to make a 2 by 3 box. 2 by 3. Bouncing around. Okay. Take your 2 term, put it on the side. 7k, negative 3. Up on top, k squared, negative 2k, and 7. Okay, even though our box is a little bigger, we do the exact same thing. Multiply to fill it out. Remember, there's a 1 in front of this k squared, if you want to put that in. Okay, so first box, top left, 7k times 1k squared.
7k.
7k to the
Second.
How many k's do you have total?
Third.
1, 2, 3, so yeah, third. Okay, you keep going. Do the top row. Make sure you keep track of your variables. How's the first row look?
Good.
Good. Start on the bottom row. We have not. You're done with the bottom row, you can start writing your final answer. Oh, bottom row. Not everything will have a K, but that should have a K to the. Yep. Yep, there will be no K. Yes, when you write your answer. So the biggest excellent skill. Yes, excellent. So you add together, that would be next. Yeah, you're exactly right. And you can keep going. They say the same when you're adding. There's your bottom row. Check it. Check your bottom row.
Yep.
Good, good, good. Now you need, the hard part is writing your final answer. Remember to look at your like term. Like term. Like term. Like term. Like term. Loner. Loner. So try and write your final answer. Combine your like terms and write them in order. Largest exponent to smallest. Oh, negative 21. 7K. Or to third, yeah. Did you add these together? Oh, it's 14. Yes, now you write your final answer. I think you can back the games. Yep, and then you're going to add together your like terms. That one up? Yeah. Oh, yeah. Keep going down the list.
Excuse me, so wait. Oh, blue go first. I'm tripping. Oh, no. You subtracted, right?
You add together, add like terms.
So we always add.
You're always gonna add your like terms.